As we have seen, integration by parts turns the integral of u dv into u times v minus the integral of v du. Sometimes what happens is that this new integral that you get on the right-hand side also needs to be computed using integration by parts. So use integration by parts once, you get this right-hand side. Now you have a new integral, but you have to use integration by parts again to evaluate the new integral. This example is a situation where we need to do exactly that. It is the integral of x squared times cosine x. Remember, the first thing we need to figure out is what we're going to set u equal to. One way of doing that, a rule of thumb, is to use this Lie list. So I look at my integral. Are there any log functions? Nope. Is there an inverse trig function? No, there's a cosine, but that's just a normal trig function. So next, there is an algebraic function. Happens to be x squared here. So since that's the first that appears on this list, that is what we will set u equal to. So we let u equal x squared, and once you know u, that automatically determines what dv is, because we're turning it into the integral of u dv. So if u is x squared, then everything else must be dv. So we see that dv must be cosine of x times dx. And now we need to figure out what du is and what v is. We'll start by finding du. That is the derivative of u, which is 2x, multiplied by dx. Next, we find v from dv by integrating. So we're going to integrate cosine of x, and that just gives you sine of x. So now we know u, v, and du, so we can apply this integration by parts formula. Let's plug everything in. U turned into x squared. Both of these v's are sine x, and du is 2x dx. Next, we should look for ways of simplifying our new integral. There is a constant factor in it, so let's factor out that too. Now we're left with the integral of x times sine of x. Now this still isn't one of our basic integrals, and it's not something you can evaluate using the method of substitution, but it's a lot like the integral that we started with instead of x squared, we now have x. So we decrease the power of x by 1, and hopefully, if we apply integration by parts again, we'll decrease the power of x one more time from a power of 1 to a power of 0. In other words, this x will go away. So that's the plan. We'll use integration by parts again to evaluate this integral. Alright, so this is where we're at in the problem so far. We're trying to figure out the integral of x times sine of x so we can finish our derivation. We're going to figure it out by doing integration by parts again with a new choice for u and a new choice for dv. So still the first function type that appears on the Lie list is an algebraic function. Here it's x instead of x squared. So we're going to let u equal x. That means that dv has to be everything else, which is sine of x times dx. Next, it's time to find du and v. Since u is just x, that means du is just dx. And we find v by integrating. The integral of sine of x is negative cosine of x. So now we'll apply the integration by parts. We'll plug in each of these quantities. The u turned into x. Both of these v's turn into negative cosine. and du is just dx in this part. As usual, we should look for ways of simplifying the expression that we got. In this case, we have a minus minus. Minus minus turns into plus. And so now we have a much simpler integral than the one that we started with. Just the integral of cosine of x, which is equal to sine of x. So this isn't the final answer to our original problem. Remember, right now we were just figuring out what the integral of x times sine of x was. So we still need to replace this with the expression that we just found. Let's go ahead and do that. Get x squared times sine x minus 2 times this quantity that we just found. And so this negative 2 can be distributed inside these parentheses. One thing I want to point out about that is when the negative 2 multiplies the c at the end, that just means negative 2 times some arbitrary constant. That is just giving you another arbitrary constant back. And so people will just write plus c, not like minus 2c. Now, I want to look for another way of simplifying the final answer. I have two terms that have a common factor of sine of x. So I'm going to factor out that sine of x. And the first sine x was multiplying an x squared, and the second was multiplying a negative 2. And that actually gives us our final answer for our original problem. You could double check this result by taking its derivative, and if you go through all the product rules and simplify, you'll get the expression that we started with.